Welcome future physicists and astronomers. Welcome to our spaceship. As of today, you were given a chance to explore and see the outer space. Come in.
Wow.
So today, we will talk about the Newtonian revolution and how this revolution changed how humans see the world. Miss Aryan, what is Newtonian revolution?
The relationship between abstract mathematical constructions and the physical system that we can perceive the world around us through experiment and critical observation was specifically developed by Newton. The core of the radical Newtonian method is the creation of a mathematical system on the mind that shares some characteristic with the physical universe. Newton was able to make his groundbreaking advancements in celestial mechanics using his approach, which ultimately led to the development of new physics of central forces and the law of universal gravitation.
That's right. Now, who is the person behind this revolution?
May I? The person behind this revolution was Sir Isaac Newton. He was an English physicist and mathematician who developed the principles of modern physics, including the laws of motion, and is credited as one of the great minds of the 17th century scientific revolution. In 1687, he published his most acclaimed work, which is Philosophiae Naturalis Principia Mathematica, or Mathematical Principles of Natural Philosophy, which has been called the single most influential book in physics. In 1705, he was knighted by Queen Anne of England, making him Sir Isaac Newton.
Indeed. Now, Newton is famous for this law. What law is this?
It's the law of motion, ma'am. Newton's law of motion related object's motion to the forces acting on it. In the first law, an object will not change its motion unless a force acts on it. The second law, the force on an object is equal to its mass times its acceleration. In the third law, when two objects interact, they apply forces to each other of equal magnitude in opposite direction. Thank you.
That's good. So out of those laws that you have mentioned, what are his inventions and discoveries? Yes, Miss Linkita.
Yes, ma'am. So the three greatest discoveries of Newton is the theory of universal gravitation and the nature of white light, and also the calculus. And of course, the invention of Newton is the Newtonian apocalypse, Newtonian law of Pauling, Newtonian's perfect coinage, Newtonian and the reflecting of light, Newton, father of calculus, the philosophers and the stones, laying down the three laws of motion, Newton calculus, and of course the Newton orbital canal.
That's right. So for you, how does Newtonian revolution contributes in science and technology?
May I, ma'am? Yes, ma'am. So, Sir Isaac Newton contributed significantly to the field of science over his lifetime. He invented calculus and provided a clear understanding of optics. He did invent reflecting lenses for telescopes which produce clear image in a smaller telescope compared with the refracting models of the time. And in his later years, he developed anti-counterfeiting measures of coins, including the radius you see on quarters today. But his most significant work had to do with forces, and specifically with the development of a universal law of gravitation and his law of motion that helped scientists understand more about the motions of planets in the solar system and of the moon around the Earth. That's all, ma'am.
That's right, Mr. Villanueva. So Newton's research on motion helped give credibility to the heliocentric view. Newton also helped pioneer telescopic innovation, and he is sometimes credited with inventing the first reflecting telescope. He also conducted experiments using the prism and developed a theory about the nature of color and light. So that's all for our discussion. Thank you for all your presence here today. You may now freely explore the area.